Hello again. Ngayon, ang sosolve naman natin is first yung weight ng diaphragm tapos yung total weight ng sidewalks, post, and railings. Kapag sinabing diaphragm, eto yun. Remember, ano? So, along the span, meron tayong tatlong diaphragm. Tapos, in between girders, tatlo rin. Okay? Yan. Since we have 4 girders, magiging 4 minus 1, meron kang tatlo in between. And then, yung 22.795, yan ay nanggaling dito sa weight ng girder, bawat isa. Okay? So, that is simply the volume times the density of concrete or unit weight of concrete, which is 23.6. No? And then this volume, you have height times width times length. And then, notice na yung height ay black, tapos length is also black, meaning dependent yan dito sa mga dimensions na binigay natin. Ang input dimension lang dito na bago ay yung width. Okay, so yung height, that is equal to the web height, which is this one. Ayan, see? Tapos, yung length naman, that is simply G, or center to center ng girder, minus the web width. Okay, so, ayan. This is center to center, 2500 minus web thickness 203.2. And then, yung width, so input data yan, 0.28062 meter. Okay? So, if you will multiply height times width times length times 23.6 will give you 22.795. Okay? So, ayan yun. Next is, so, ibig sabihin, alam nyo kung ano ang ilalagay na value dyan. Hindi lang basta-basta na mag-i-input ka riyan. So, magde-depend yan sa dimensions ng mga structures mo. Next is, dito na tayo sa 15.747. Paano nakuha yan? Take note that this is total weight of sidewalks, posts, and railings. And then, kapag sinabing sidewalk, yan din yung tinatawag na curb. Okay? Sidewalk or curb. Tapos, you have the railing and then the post. So, dito tayo ngayon sa curb or sidewalk. Ang sidewalk or curve, ito siya. Okay? Yan. And then, yung railing, ito yan, yung horizontal structure. Okay? Considered as concrete section. You have 0.2 and then 0.3 din yung height. So, parang minimum beam section. Ano? And then, yung post naman, ayan, parang columns yan at spacing of 2 meters. 2 meters ang nilagay ko. So, ang dimension, square post yan, 0.25 by 0.25 by height na 0.79. Input data lahat yan, and then spacing is 2 meters. Next is, punta tayo ngayon dito sa computation ng sidewalk. That is simply the area, cross-sectional area of the sidewalk multiplied by density of concrete. Yan. So, kilonewton per meter yan. And then, sa railing naman, magiging kilonewton per meter din. The cross-sectional area multiplied by unit weight of concrete. Ayan siya. And then, sa post naman, i-convert natin ito ng uniform load or kilonewton per meter. That is, minultiply natin yung volume ng concrete. Ito siya. So, width times height, which is ito. Okay, width times height. And then, minultiply natin siya ng density of concrete, tapos dinivide natin ng spacing na 2 meters. So, magiging kilonewton per meter ang dating niya. Tapos, sa utilities naman, ito yung mga nakasabit sa ilalim ng slab, no? Yung mga tubo, communication lines, transmission lines na sinasabit yan sa ilalim. So, let's say naglagay ako ng 1.67 kilopascal or kilonewton per meter squared. Next, i-convert natin yan into uniform load. So, you simply divide this 1.67 by the width of the curve, or that is input, okay, divided by curve width na 1.4. Okay, so yan yung 1.19. Next is i-total natin lahat yung mga weights. So we have sidewalk plus railing plus post plus utilities. Oops. Okay, so ulitin natin. I-add natin si sidewalk plus railing plus post plus utilities, then yan. So 15.747. Yan yung nilagay natin dyan. Okay? So pwede ko ng equal sign and then yan. So I'm just showing you na hindi ka basta-basta maglalagay ng numbers dyan. Magde-depend yan sa mga dimensions ng mga structure mo. Okay? And then next we have design moments at midspan. Remember that our structure is designed as a simply supported beam. Kaya zero moment at ends and then maximum moment at midspan. Okay, so meron tayong future wearing surface. Yan yung asphalto na ipinapatong sa thickness of slab, ano? Yan yung, let's say, naglagay ako ng 83 mm na asphalt overlay 1.05. So this is input data. Tapos moment due to girder weight, and then moment due to diaphragms, slab and haunch weight, then moment due to future wearing surface, sidewalks, post and railing weight. Take note, kasali na rin dito yung utilities. So all in all, parang ito yung dead load natin, tapos ito naman yung live load. Sa pag-compute ng live load, kinonsider natin yung truck loading na MS18. Okay, so we will go here later on. And then let's look at the computation of moments based on this figure. Yan. So for uniform load, we have WL all over 8. Okay? Wherein W, or that is the uniform load, is kilonewton per meter. And then L is in meter. Tapos, etong P, that is moment at midspan, is PLL over 4. This is if you have one diaphragm only. If you have two diaphragms, PLL over 3 ang moment. And if you have 3 diaphragms, you have PL all over 2. So, applicable itong WL all over 8 for uniform loads. And then, yung PL all over 2, applicable ito sa diaphragm natin. Okay? So, WL all over 8, tsaka PL all over 2. So, balik tayo dito ngayon sa design moments at midspan. Moment due to girder weight, magiging WL squared all over 8 ang kalalabasan yan. Yan. So, ang ating L is yung 30 meters. Okay? Ito si L. Yan. Girder design span length L is 30 meters. So, split lang natin yan. Tapos, itong W natin would be the area gross multiplied by the unit weight of concrete. Okay, so let me show you. So, 23.6 multiplied by the area gross. Dito natin yan kukunin sa gross or basic section properties. Ayan. And then 699,998.6. Take note that that is in millimeter squared. Okay, so you have to divide this by 1 million para maging square meter. Yan. Next is, so yan na yung ating W. Multiply na natin siya ng L squared all over 8 times L, nasan si L? Ito, yung 30 times 30 ulit divided by 8. Yan. Okay, so yan ang procedure paano kunin itong 1858.5 na yan. Next, dito na tayo ngayon sa moment due to diaphragm, slab, and haunch weight. Itong diaphragm, tatlong diaphragms yan. So, PL all over 8 ang gagamitin natin dyan. Tapos yung slab tsaka haunch, WL squared all over 8 ang gagamitin na natin. Kasi, considered as uniform load yan. So, kukomputin natin tatlong separate moments. You have the diaphragm, slab, and then the haunch. Okay? So, ito siya. For the moment diagram, so magiging M is equal to PL divided by 2. Okay? So, nasan si P? That is diaphragm. Kaya, punta tayo dito. Weight of one diaphragm carried by each girder. Ayan yun. Tapos, si L times 30 divided by 2. Yan. So, yan yung 3 for 1.92. Next is, punta na tayo ngayon kay moment due to slab. Again, that is WL squared all over 8. First is, kukunin natin yung uniform load na W. And that is 23.6. Take note that slab is concrete. Multiplied by area. Ano ba yung area na yan? It is thickness of slab. Okay, ito siya. Thickness of slab, 180. Then, multiplied by girder spacing with G, which is, asan si G? Yan. 2,500. Next is, since this is millimeter squared, i-divide natin siya ng 1 million para maging meter squared. Next, i-multiply na natin siya ngayon. Yan na yung ating W. Multiply na natin siya ng L squared times L, this is L, times L ulit, divided by 8. Yan. Okay? So, yan ang procedure paano nakuha si moment due to slab. Next, dito tayo, moment due to haunch weight naman. Again, haunch is this part. Okay? Ito yung na-compute natin due to slab, tapos ngayon due to haunch. Yan. So again, 23.6 multiplied by the area. Or, unahin natin yung area muna, no? So, equal sign. This is trapezoid, diba? Si haunch. So, ang ating dimension would be haunch top width plus haunch bottom width, and i-divide natin yan ng 2. Okay? Next, i-multiply natin to ngayon ng thickness. So, dito ako mag-click-click. Tapos, hanapin ko si thickness of haunch. Ito siya. Ayan. Haunch thickness of slab. Oops, mali. Ito pala. Haunch bottom width, haunch top width. Ito yon, 80. 100. Okay, so yan. Yan. Then I will press enter. Oops, ulitin ko. Yan yon. Haunch thickness, and then I will press times. Next. So, meron na tayong cross-section ng trapezoid. We now multiply this by 23.6 times. Okay? Pero, note that the area is again in terms of millimeter squared. So, i-divide natin yan ngayon ng i-divide natin siya ng 1,000 para maging meter squared. Next, we now multiply this by, okay, take note na kapag meron kang division, gumamit ka ng parentheses. So we now multiply this by the distance or length na 30 times 30 divided by 8. Okay? So, yan na. Meron na tayong moment due to haunch. So, yan yung procedure. Paano nakuha yan? 309. Next, etong moment due to diaphragm, slab, and haunch weight, that is simply the sum of the three. Moment due to diaphragm, moment due to slab, and moment due to haunch. Ayan, okay? Next, dito na tayo ngayon sa moment due to future wearing surface. FWS is future wearing surface. And that is equal to WL squared all over 8 again. Ngayon, magde-depend yan dito sa FWS. Okay, so 1.05 multiplied by the girder spacing divided by 1,000 para maging meter yan. Okay, next. Okay, ulitin natin. Para sa moment due to future wearing surface, sidewalks, tsaka post and railing weight. So, unahin natin si future wearing surface. And that is 1.05 times yung road width na 8 meters. Ito. So, roadway width is 8 meters. Dahil, yung buong 8 meters ang kokoberan natin ng asfalto. Tapos, ang asfalto, i-divide natin yan sa 4 na girder. Okay? Divided by, how many girders do we have? Ito, number of girders is 4. Next is, pero, hindi lang yan ang bubuhatin ng isang girder. Let's say, isali na natin ngayon yung post and railing tsaka yung sidewalk, which is yung 15.747. Ayan. Sidewalk, post, and railings. Okay? So, next, i-distribute na natin yan sa 4 na girders. Number of girders, ayan, 4. Then, meron na tayong W. Okay, i-apply na natin yung equation na WL squared all over 8. So, 6.04 now. Gawin ko lang naka-enclose dyan. Times L squared all over 8. L, yan yung ating 30. Length na 30, ano? Times 30 divided by 8. Yan. So, yan yung equation para makuha yung moment due to future wearing surface, sidewalks, post, and railing weight. And then, next, punta na tayo sa computation of live loads. So, this is now based on truck loading na MS18. Dito sa ating input, nakalagay dito na, ayun, nasan siya? Ito, traffic loading, input 18 for MS18. So, if you will check sa formula, walang connected dyan, ano? Pero, dito natin siya gagamitin. Computation of live loads, or this is the truck loading. At ang ating gagamitin ay MS18. Galing to sa code. So, let me show you what is MS18. Yan. So, yung wheel A, ito yung gulong na nasa likod. Tapos, wheel B, yan yung nasa gitna. And then, wheel C, yan yung front wheel nung trailer. Okay, so trailer, tapos yung humihila, tapos yung kanyang hinihila. And then, between C and B, we have 14 feet. Take note na ito ay English na naman, ano? Dahil American yan eh. Pero, meron na tayong load na 36 kilonewton, tapos at point B, we have 144, and then A, you have 144 also. Notice na B tsaka A parehas silang 144 dahil inassume niya na yung binubuhat niya is distributed equally on these two wheels. Okay? Tapos, eto naman, ang bumubuhat dito sa makina tsaka din sa cab is wheel C. Yan yung 36 kilonewton. And that is for single line ng gulong sa isang side lang. Notice na dalawa yan, yung kaliwa at saka yung kanan. So, total, you have 36 plus 36. So, magiging 72 kilonewton. Correction. Okay, so, yung 18 na yan, nanggaling yan dito sa 36 divided by 2. Okay, so split ko lang. Ayan. So at point C, the weight that is carried by the wheel, the total weight is 36 kilonewton. Ngayon, yung bawat gulong 36 divided by 2 will give you 18. Next, at point B naman, 144 divided by 2 will give you 72. Okay, so input data yan, magdedepende sa type of loading. In this sample, gumamit tayo ng MS18 na loading. Okay, MS18 or HS20-44 na loading. And then at point A, dito, o sa likod, that is also 144 divided by 2. Yan, 72 kilonewtons. Next is itong between C and B, that is 14 feet. So 14 divided by 3.281 will give you 4.27 meters. Yan yon. And then dito naman for dimension B, between B to A, ginawa ko na rin na 4.27 meters. Pero in reality, pwedeng more than 14 meters yan. Ay, more than 14 feet. Pwedeng umabot to ng 30 feet. Okay? Pero naglagay ako ng, ginawa ko na rin siyang 14 feet para ma-maximize yung moment. Kasi may tendency nun, baka sobrang haba nito, yung gulong nasa labas na ng span. May instances na ganun. To the point na yung gulong mo, nasa labas siya ng bridge, ang nasa loob lang ng bridge yung C and B. Things like that. Okay, so yan yung paano nakuha yung mga input data na yan. And then, we will now take moments. So, taking summation at A, we load, dito tayo. So, the resultant of the three wheels is 72 plus 72 plus 18 will give you 162 kilonewtons. And yung 162 kilonewtons na yan, syempre, nandito yan somewhere in the middle of these two wheel loads, 72 and 72. Okay? Kaya, summation moment would be summation moment would be 72 kilonewtons multiplied by 4.27. Dito tayo nag-take moment, ha? 4.27 plus 18. Dito na tayo, point C. Times the lever arm na 4.27 plus 4.27. Yan. And it will give us 461.60. Okay? Ayan yon. Next, and if I will click this, nakalink din siya doon. Okay? Next is, paano natin makukuha yung location ng reaction. All you have to do is divide this summation Rx, yung 461.16, divide that by the total load or the resultant load, which will give you 2.85 or 847 liters. Okay, so ayan yun. And then, dito na tayo ngayon, distance of resultant from B. Ito yung ating resultant. What is its distance from point B? Which is defined as eccentricity E. Okay? So, that is obviously from the figure 4.27 minus X. Okay, so that is 4.27 minus X na 2.847. Okay, so that is 1.423. Or, eto siya. So, 2.847, 4.27 minus this. Next is yung eccentricity divided by 2. Or that is the distance of resultant to center of bridge, which is simply the same as E over 2. Okay? Ganyan. Yan din yun. Okay? E over 2. So that is the distance of resultant to center of bridge. And that is eccentricity divided by 2. Okay? So, E divided by 2. 0.712 meters. Next, i-check natin ngayon kung lahat ba ng gulong nasa loob ng bridge. Okay? So, that is the criteria for maximum bending moment. Dapat lahat ng gulong nasa loob ng bridge. So, to check that, i-add natin ngayon itong this distance naman, which is basically the same as E over 2. Okay? So, this distance, E over 2 plus 4.27, dapat nasa loob siya ng L over 2, or it should be less than L over 2. So, let's check. That is 4.27 plus E over 2 is equal to 4.98. Okay? Ayan siya. Next, what is L over 2? It is 30 divided by 2. So, 15. So, 4.98 is less than 15. Or less than L over 2, which is 15 meters. So, ibig sabihin, lahat ng gulong nasa loob ng bridge. Ayan. So, therefore, all three axles are on the span. Now, let's take moment at left support to get the reaction at the right. So, based on this figure, nasan kaya yung malaking reaction dito? Okay? Would it be at this end or this end? So, let's cut a section at wheel B. Okay? So, ang i-consider natin ngayon na forces, you have the 18 with lever arm 4.27, tsaka yung reaction with lever arm na L over 2 minus E over 2. Okay? So, kunin natin yan. Summation moment at point B is equal to 0. Okay, so that is equal to 18 times the lever arm na 4.27. Okay, tapos